Okay, so good afternoon, everyone. We are here with our research on revolutionizing a distance measurement system, and we are the research scholars of Vishwakarma Institute of Technology, Pune, with the names Riddhi Sonamne and Vedant Sawant. And our research is guided by Kaushalya Thopte, ma'am. So, have you ever thought of measuring distance from an IoT system? So here we are with the measurement of distances from 2 to 3 coordinates in one point. Now, in the traditional system, you might have seen some system which use ultrasonic sensors. Now, whenever we call ultrasonic sensors, you might be having the ultrasonic sensors might be having some limitations, and that are regarding accuracy only. So we are here with the new technology, with the latest technology, that is time of flight, which offers us a good type of accuracy, and that of we are calculating the area, we are calculating the region of the area. So our system is great in the part of accuracy. This is some of the literature survey. I will just scroll it. So we had found a lot of disadvantages in the earlier systems. So this is the architecture of our system. We are using 3 components, that is a TOF sensor. This is the main component in our system. Then we have node MCU, which is the main controller of the system, who will look after the controlling to the systems. We have two push buttons. One push button plays a role of unit conversion, and another push button plays role of the unit measurement. And then this whole system is actually connected with internet and an app that is nothing but Blink, which is a mobile interface and as well a web interface. So now let me tell you, let's go through whole modules which we have in our research. So the first module is time of flight, as this is the replacement of ultrasonic sensor. Let me explain you how this module actually works. So this TOF sensor has a laser transmitter, and how the measurement or how the distance to the object and the sensor is calculated, I will be telling you that now. So this actually has a transmitter, and this throws a laser to the object, and afterwards the laser comes back to the receiver of the sensor. In this way, the time of the passing of the laser and coming back to the receiver is calculated and is returned to this time of flight, and this measurement is actually stored in our system and further used for area calculation. So our major motive is to calculate the area of something and to identify which shape it is. So next modules, I'll call upon Riddhi to explain further.
So the now next module is area calculation. That is the important module in our system. So basically there are multiple rangefinders available, but our main motive was to commercialize that rangefinder to that particular extent where a user can determine the area of the region that is being calculated by just using this rangefinder system. So initially our system is able to identify the shapes that are quadrilateral regions, such as square, rectangle, or rhombus and parallelogram, and this can be used in industrial works. So the next module that we have is unit conversion. So there are multiple standard units available. So initially, as the TOF measures the distance in millimeters only, so we are providing a functionality for changing that particular distance that is being measured into multiple standard international units, such as meters, feet, or inches. So then next up we have that is display module. So we are providing the display on the Blink application that is connected to the ESP32 via Wi-Fi. Not only on the mobile app, we are also displaying all the results or the data that is being calculated on the web UI of the Blink application. And now we'll be talking about the results and analysis that our system has. So this is the deviation in the measurement. So we have given error tolerance of +-1. So any error between, that is the deviation between the measurement, is tolerated up to the 1 centimeter up or down. And this is the deviation for multiple regions that is shown in the bar graph. So the next step is analysis of area calculation. So basically for quadrilateral regions, 4 dimensions are taken, which are side 1, side 2, side 3, and side 4, and based on comparison of these values, the shape is determined of that particular region. So this is the analysis of some of the values that system gave us. So considering all these factors and results, the overall system accuracy that we measured is 95%, as the error tolerance is plus minus 1. The next up, in the conclusion, as we have accuracy up to 95%, we aim in future to increase that up to 99%, where the error tolerance will be reduced by enhancing the TOF technology itself. And in the area determination module, we aim to recognize shapes that are different than quadrilaterals, namely the triangular regions or the circular regions. We also aim in area calculation of that particular region. Next up, we have the few video of our system that we'd like to show. So this is basically a rectangular region that has been calculated using our system, and there is a push button provided from which we can calculate the distance, and the result will be displayed in the next slide. There is screenshots are provided for the same. So this is the web interface for the system, and this is the application interface. Thank you so much.
Good work, ma'am. Good work. Thank you.
Thank you so much. Thank you.
So shall I